Good morning, everyone. So, last time we have seen about the characteristics of magnetic field lines, which is produced by the bar magnet, and not only that, we have seen also the magnetic field line, the shape of magnetic field lines, which is produced due to the current carrying conductor, in which generally we have seen a current carrying conductor which is straight line, right? So, generally, if we are using a loop instead of a straight line, then what is the change will be occurs in a magnetic field lines? Just think about it. Our last lecture, in which we have seen that whenever the current is passing from the conductor, the magnetic field lines is produced around it, which is a same-centered, a circular in a shape, right? But if we are using a loop, the thing is that what is loop? Loop is also one type of conductor, but it is made like a closed circuit, a closed path. Like if we are using a metallic rod or a metallic wire or something like that, and if you just fold it in some shape like a circle or a rectangle or a square or something like that, then you can say that this is one type of loop. If you are thinking about one of the loop, then just think that here it is one conductor which is in a circular shape, like that. Okay? And here it is, this one is the whole conductor which conducts the current. Now for conducting a current, we are just connect the ends of it with a battery. Then here it is one battery. And with battery that you have to connect a key also, that you can stop a current at any time, or if you put a key inside of it, the current can be flow at any time, right? From this you can say that here is the positive pole and here is the negative one. So the electric current will flow from positive to negative, then the direction of electric current is like that. It's just going from positive to the negative, right? The voltage of the battery is V, and here it is the key K. As I have put at a key, the current is flowing from positive to the negative. Now, as you know that the current is flowing from the conductor, and as the current flowing from the conductor, the magnetic field is produced. Just think about a single rod, like that. If the current is flowing in it, then on which point the magnetic field is produced? Is it on the ends of a the conductor, or is it a midpoint of a conductor at where the magnetism is produced? क्या ये magnetism इसके end point पे produce होगा या फिर mid point पे होगा? The question is there. Then you can say that the current is flowing from the whole conductor, not from any of the point. So the magnetic field lines which is produced in the conductor is at each and every point of that conductor, means at here, on each and every point that magnetic field lines are produced. And here it is one conductor, so here like that. At each and every point that magnetic field lines are produced, and which are not intersect with each other also. Understand? If here it is, then exactly besides this there is one another point, and there is also the magnetic field lines is produced. So whole conductor magnetized. Understand? Like that, if the current is flowing from this conductor, which is a loop, then at each and every point the magnetic field lines are produces. Just think about the symmetric point, that one at here and one at here. The magnetism is produced, so the magnetic field lines like that, which is circular to that conductor, like that here also. Then from this figure that you can say that if there is a symmetric point, if you are thinking about it, then at there the two magnetic fields are produced. So it makes that magnetism increases. As there is a 2 point, just think about a conductor, then there is a number of magnetic field lines are less as compared to the loop. because in the same region the 2 times magnetism is produces at here. So at here, like that. Understand? So at each and every point this type of things occurs at 2 symmetric point and a 2 symmetric point that the magnetism is produced. But as you know that the magnetic field lines never intersect each other. So at here they are so near to each other, and when it just comes on the center, they never touches to each other, so they becomes a straight line, and they are just passing from the center of a loop like a straight line. If there is a loop like that, then the central magnetic field line is like that, a straight line passing from the center of it, as it is always perpendicular to the conductor. As you know that if here is conductor, magnetic field is like that, a circular. Then think about a loop. Then all the magnetic field lines are just in a circular shape from that conductor, but the central one is a straight line which is passing from the center of that loop. Understand? So the central line will become a straight. Not only that, in a center the magnetic field lines are more closer to each other. So the maximum magnetism is in a center. The maximum magnetism. The maximum magnetism is in a center, as the magnetic field lines of both the conductors, mean both the symmetric points, just comes more nearer at the center. As at here, the magnetic field lines of this point and this point just comes there. So both the magnetisms are near to each other, the lines becomes more nearer, they become straight, and just because of that you can say that the maximum magnetism is produced at here. And if the radius is less, the magnetism is higher. If the radius is higher, because you know that if you are thinking about a conductor, these lines are nearer, and as distance increases, lines becomes more from each other. So if the radius is less, then these more lines can be easily comes near to each other, and if the radius is larger, then these spaced magnetic field lines come nearer to each other. Understand? So as the radius increases, the magnetism of center point is decreases, and as the radius is decreases, the magnetism on a center point of a loop is increases. So you can say that the magnetism is inversely proportional to the radius of loop, which is inversely proportional to the radius of loop. So if the radius is decreases, the magnetism is increases, and if the radius is increases, the magnetism is decreases, which is can be said by this one. When the loop is made and the current is passing from it during that time, from the two symmetric point of that loop, the magnetism is produces which are inside of a loop. Inside of a loop, they comes near to each other, and just because of that, the magnetism is increases, right? So the magnetism is increases, and in the center point, that the magnetic field lines of a loop is a straight one, right? So the maximum magnetism is produced on the center, and as the radius is increases, the magnetism on a center is decreases. This is the magnetism in a center of loop. In a center of loop, which is decreases as the radius is increases. So here it is the magnetism produced by a current carrying loop, and by this loop we have to make a one solenoid. Solenoid is one of the most important point, the most important topic for this chapter, because it can be asked you for 3 months, sometimes for 4 months also. And not only that, it is a vast application in a electromagnetism, right? In electromagnetism, it has a vast application, the solenoid. Then what is the solenoid? Solenoid is a one type of coil that is made by conductor. whenever you wound a conducting wire on a one cylindrical core, during that time it makes a coil which is known as solenoid. That you have to wound a wires on in a cylindrical shape, right? You have to wound a wire on the cylindrical shape. That wire should be a conducting, that the current can easily pass it, and as the current passes, the magnetism is produced, right? So it is a one type of coil. Like if there is one conductor is just wound like that, it should be spaced from each other. They should not be connected with each other, right? It makes a shape like a spring. There you can see the spring in which the wires are just round and round and round, and they make a one cylindrical shape, which is the solenoid, right? And this solenoid has so many loops. It is not made up of one loop. If you think about it, then you can see there's so many loops. Loops is a circular shape of a wire. Generally, I am not saying always circular, but you can say that the circular shape of a conductor. That you can see in a spring. There is so many circular shape means there is so many loops. If you are thinking about the n loops, then the magnetism produced by that loop is n times higher than the one loop. Than the one loop, right? If from one loop some of the magnetism is produced, then from 10 loop the magnetism is 10 times higher. If the loops are 12, then the 12 times higher. If it is 15, then the 15 times higher, and if it is n, then the n times higher. Then the magnetism produced by the loop can be n times higher if the turns of that loops are n. So we are just thinking that here it is one of the solenoid, in which there is so many turns are there, and they are making a single loop at each and every point, right? Now, if we connect this solenoid with one battery and the key, here is plus, minus. As the key put it inside, the electric current flowing from it. So, it just comes like that. In this direction, in this direction. Here, like that. It comes in here. So just watch it here. This portion. Just think about a three-dimensional figure, okay? Just imagine it. According to the three-dimensional figure, this figure is just like that. Here it is the portion which is black, and here it is the portion which is blue. Understand? So our loop is like that. In a board, it is like that. The one portion is outside of the board and the other portion is inside of the board. Then you can say that in each and every outside of the board, the current is in the same direction, in a downward direction, right? And inside of the board, in all them, the current is in an upward direction. So the magnetism is produced in the outside of that is same, and inside of it is also the same, right? So the magnetism produced at here, if we are applying a right hand thumb rule, then according to it, the current is in a downward direction, so the magnetism is like that. So the magnetism produces is in this direction. If we are thinking about it in an upward direction, it is like that. So it is in this direction. So inside of the loop, it is in a one direction. Inside, it is in this direction. Inside, it is in this direction. All loop has the same thing. The direction of magnetism is the same. And as we know that, inside of it, it becomes a straight line. So whenever we just apply a vector summation, it gives us a magnetic field lines like that, which is same as a bar magnet. Because in a loop, the magnetic field lines in this one is like that, and the direction is from here to here, like that. right? According to the right hand term. Here it is also same, but the magnetic field, the current is in a different way. In this downward direction, so it is clockwise. It is in upward direction, so it is anti-clockwise. It is just going like that, and it is just going like that. So, in the inside of loop, the direction of that magnetic field is the same, like that. All loop has the same thing, and just because of that, you get the vector summation of these magnetic field lines. So, inside of it, it is a straight line, and outside of it, when you make a sum of it, it just gives a magnetic field lines like a bar magnet. And as it gives it as a bar magnet, its one portion, means one end of it, is act as a north pole and one of them as a south pole. From the direction of magnetic field lines, you can find out which one is a north and which one is a south. As according to the characteristics of magnetic field lines, outside of the magnet, it is from N to S. And inside of it, it is S to N. So inside of it, we have just proved that the magnetic field lines is like that in this direction. So it should be S and here it is N. Then the magnetic field can be going in this direction. So here it is S and here it is N. So one of the end of a solenoid is act as a south pole and one another as a north pole. So here it is your solenoid in which the magnetism is produced which is N times higher than the magnetism produced by a single loop, as the turns of a solenoid is N. So with the help of solenoid, you can produce a more magnetism which can be used in many applications, because that can becomes a bar magnet whenever you flow a current, and if there is no current, it becomes an ordinary conductor. But whenever you flow a current from it, it magnetizes and becomes a bar magnet. So like that, it can be used in so many applications, right? Once again, I am just what is solenoid, right? Then the solenoid is a one type of conductor which is wound in a cylindrical shape but separate from each other. Then this whole structure is known as a solenoid. In solenoid, whenever you connect a battery and a key, and when the current is passing from it, in each and every loop, the current flowing from it is always the same, and just because of that, the magnetism produced by each coil is each loop is same. So you have to take the vector addition of the magnetism and you get a higher magnetism which is N times higher if the turns of a solenoid is N, right? If we draw a magnetism produced by a solenoid, then you can see that the magnetic field lines are same as the bar magnets. Just because of that, its one end is act as a north pole and the second end is act as a south pole. Not only that, just look at here, inside of the solenoid, all the magnetic field lines are parallel to each other. Inside of the solenoid, inside, the magnetic field lines are parallel. So each and every point inside of the solenoid, the magnetism is same. But outside it becomes less or more according to the nearness of magnetic field lines. But inside it, the magnetic field lines are parallel to each other, and just because of that, they are same. The magnetism is same in it. Just think of it, if I put a soft iron rod inside of the magnet, inside of the solenoid, what happens? If I put a soft iron piece inside of the solenoid, then this solenoid produces a magnetism it uses to magnetize this loop. Whenever current is passing from it, the solenoid magnetizes, right? And that magnetic field uses an iron rod to magnetize it. This whole structure is known as electromagnet. This whole structure is known as electromagnet, which can be used in a crane to carry any heavy load like a car or something like that. We have used this electromagnet in a hydropower plant or something like that, in which that you have to carry a heavy loads, in which the irons are generally used, that the magnet is always attract the iron. So whenever there is a car and if you use a crane on it, right, then flow electric current, it becomes electromagnet. So it is magnetized, then you can put it up. Now whenever you put a down, just put it down, to stop the electric current, and you can easily carry this conductor because it doesn't now become a magnet. So like that, it can be used in a crane. Not only that, in a microphones, speakers, also the electromagnets are used in which a sound is produced, sound is converted into electric signal or something like that. In all these types of electronic devices, generally electromagnets are used. Motor, generator have also the electromagnets, in which generally the permanent magnets are not used, but whenever the electric current is passing from it, it magnetizes and becomes a magnet, and with the help of that magnetism, the motor and generators are work. So these electromagnets can be used in motor, generator, microphones, speakers, and heavy load carrying cranes also, right? So here is our topic of the current carrying conductor in a loop shape, means magnetism produced in a loop and a solenoid. The another topics that we will see in a next lecture. Thank you.